Welcome. In this video, we are going to see the derivative of a function on a point, which is the continuation from the previous video in the study of derivatives. So from the previous video, we knew that slope is equal to f dash of x, which is the rate of change of a function with respect to a variable, in this case x, is also expressed in a limit as the limit of f of x1 plus delta x minus f of x1 divided by delta x when delta x tends to 0. So in this video, in the study of derivative of a function on a point, we are going to see the relationship between this function and the definition of a derivative. So for that matter, we are going to be using this function f of x is equal to 3x squared plus 12 at a point x is equal to 5. So the point x is equal to 5 is actually our x1. So we are going to try first to use the expression that was given and then compare the result we have with the definition of derivative. So limit when x tends to x1 of f of x minus f of x1 divided by x minus x1 becomes limit x tends to 5, our x1 is 5 given here, is equal to f of x, our function without any modification, which is 3x plus 12 minus f of x1. So wherever we have x, we replace by x1, and the value of x1 is 5. So we have 3 into 5 squared plus 12 divided by x minus 5, which is our x1. We have limit x tends to 5 of 3x plus 12, well, this is x squared actually, minus, so we have 5 squared 25 into 3 75 plus 12 87 divided by x minus 5. So if you continue, x tends to 5, we have 3x squared plus, we have 12 minus 87, so this is plus minus 75 divided by x minus 5. So limit when x tends to 5 of 3x squared minus 75 is divided by x minus 5. When you use limits, usually what we have to do is we have to find a way to simplify whatever we have in the denominator with whatever we have in the numerator. What we do now is that we try to factorize this 3x squared minus 75 by making it equal to 0. So this gives us x minus 5 into x plus 5 in terms of factors. So we replace this in our expression, but this itself is not going to satisfy our equation, so we multiply it by 3. So limit when x tends to 5 of 3 into x minus 5, x plus 5 divided by x minus 5. So now we can simplify this and this, and as we simplify, now we can just replace, because if you substitute x by 5 wherever we have x over here, it's not going to be division by 0. So we have 3 into 5 plus 5, which is 30. So this expression gives us 30 as the value of this function at that point, which is x is equal to 5. So now if we try to apply the definition of derivative, we have limit when x delta x, now is no longer x, delta x tends to 0 of f of x1 plus delta x minus f of x1. All of this is divided by delta x. So as a result, we have limit when delta x tends to 0 of, now in our function, wherever we have x, we are going to replace by x1 plus delta x, which is this, and wherever we have x, in this case we are going to replace by the value of x1, which is 5. So our function now becomes 3 into, it was x squared, so now it becomes x1 plus delta x squared plus 12 minus, this function is f of x1, which we saw from the previous case that is equal to minus 87. So we can just put over here minus 87 divided by delta x, which we don't know. So we have this term over here which actually can be expanded. So this expansion is of the type a plus b squared, which is actually a squared plus 2ab plus b squared, and a is 5, b is delta x. So let us expand it. So when we expand it, we have limit while delta x tends to 0 of 3 into our x1 is 5 plus delta x all this square plus 12 minus 87 divided by delta x. Now replacing by the expanded term, we have limit delta x tends to 0 of 3 into these expanded is going to be 25 plus 2 times 5, which is 10 delta x plus the square of b, which is delta x. All of this plus 12 minus 87 divided by delta x. We saw from the previous case that this was equal to minus 75, and we have limit when delta x tends to 0 of 3 into 25 plus 10 delta x plus delta x squared minus 75 divided by delta x. So this gives us, we now multiply this 3 with this, and with this. So we have limit delta x tending to 0 of this becomes 75 plus 30 delta x plus 3 delta x squared divided by delta x minus 75. This and this will cut, and still we cannot replace delta x by 0, but we can take this delta x, which is common from here and here, and as a result we have limit of delta x tending to 0 of delta x into 30 plus 3 delta x divided by delta x. So now we can simplify this and this, and because we have simplified, now we can directly replace the value of delta x by 0. So we have 30 plus 33 into 0 divided, well, 1, there's nothing else over here. This gives us 30. This value is the same as the value we had when we calculated using the first given expression. So with this, we can conclude that the definition of derivative expands also for this expression when we are talking about a point on a function. So with that in mind, we can conclude that the derivative of a function at a given point is given not only by this expression, which was the one we found in the previous video, but also as the limit of a function f of x minus f of x1 divided by x minus x1 when x tends to 1, being f of x the given function which is differentiable at the point x1.